According to the legend, a young Goss was once punished by his teacher by being told to add together the first 100 numbers, 1 plus 2 plus 3, all the way up to plus 99 plus 100. His teacher hoped this would take him a while, but Goss just thought about for a little bit and answered 5,050. Was Goss a human calculator? Nope. He just figured out the trick for summing arithmetic series. In this case, what Goss noticed was that certain parts of the sum were equal. Like, take 1 plus 100. That's 101. Take 2 plus 99. That's 101 again. This is also what 3 plus 98 is, and 4 plus 97, and so on, all the way up to 50 plus 51. We don't want to go past this because the next one would be 51 plus 50, and that'd just be repeating itself. So how many pairs are there here? There's 50 because we have 100 numbers total, and pairs have 2 numbers each, so you just divide 100 by 2 to get 50 pairs. So if we have 50 pairs that all add up to 101, you can just do 50 times 101 to get the total sum of 5,050. Yay. So, can we do this in general though? Let's see. First, we have to figure out what we're generalizing. So let's define an arithmetic series. An arithmetic series can start with any number. Let's just, for a general one, let's just say it starts with x. To get the next term, we're going to add what's called the common difference. In this case, we'll call the common difference d. This means that the next term will be x plus d. So common difference is d, next term x plus d. Now what's the next term? Do we just pick another number and add it? No. This is why d is the common difference. Once again, we're going to add d to get x plus d, or else x plus 2d. The next term, which you can probably guess at this point, will be x plus 2d plus t, or else x plus 3d. And in a series, you add terms, so we have this. Now you could keep going forever, and that would give you an arithmetic series, specifically an infinite arithmetic series. For now, though, let's just consider finite arithmetic series, or ones that n. So let's just say we're going to have n terms in this series. But since d, we only add d starting on the second term, that means that the last term in this series will be x plus n minus 1 times d. Because in the second term, there's only one d, and in the third term, there's 2 d's. So at the end, on the nth term, there will be n minus 1 d's. Okay, so that's an arithmetic series. And you can see how this saddest 1 to 100 is an arithmetic series because the x is 1, and the common difference, or d, is also 1. So we're adding 1 here, we're adding 1 here to get 1 to 2, 2 to 3, and so on, each time adding the common difference of 1. So what's the sum in general? Well, once again, just like we did the trick for 1 to 100, we can pair up terms. So here we'll have x and this term, which adds up to 2x plus n minus 1d. And this term plus the one right before this, which I didn't write, but would be x plus n minus 2d, would again add up to 2x plus n minus 1d, and so on. Here though, there could be the problem of what if there's an odd number of terms. In this case, there was an even number, so you could pair up everything. But if there's an odd number, there's going to be something in the middle. Well, what will that thing be in the middle? There's going to be, of course, the x plus n minus 1 over 2, because if it's odd, to find the number in the middle, you subtract 1 and divide by 2, d. So that's the one in the middle. And as you can notice, this is half of what the pairs add up to. So remember, in this case, we took the total number of terms, 100, and divided by 2 to figure out how many pairs there were. We can do that again, and it will even work if n is odd, because since this is half of it, that half we get when we divide by n will be half of what the sum of pairs is, and which will equal this. So in general, the sum is n divided by 2, which will be the number of pairs, or else the number of pairs plus that leftover 1, times 2x plus n minus 1d. Now this looks kind of weird, but you can also just remember this by writing it more like this. So, which equals number of terms divided by 2 times first plus last. That works for this. Okay, so we had that this equaled 5,050. So how many terms are there? 100. So we have, from this one we have 100 divided by 2 times first plus last, which, so we can remember, was 101, equals 5,050, because this is 50 times 101. And let's just try a simpler example that we can also just check. So let's erase this so you have room. Let's just try 4 plus 6 plus 8 plus 10 plus 12. We can quickly just add this up. 4 plus 6 is 10, then 18, then 28, then 40. So the formula should give us 40. So how many terms are there? 1, 2, 3, 4, 5. So 5 terms divided by 2, and you can see this is an odd one, so we're also checking that that worked. First term was 4, and the last term was 12. So now we have, so this is 5 over 2 times 16, which will be 5 times 8 over 40, which is what we were supposed to get. So that's how to sum an arithmetic series. Just remember, only use this trick if the difference is the same each time. So it's a common difference in an arithmetic series.